Hello. Hello. Good evening.
Good evening, sir.
Yeah, I'm a little bit
Good evening,
late.
sir.
Okay.
Good
Uh,
evening, sir.
okay. All right. No problem. All of you are welcome. And let's see how it goes. Okay. Uh, this part you have to. Okay. Now this thing is this. Can you see the screen?
Yes, sir.
Hello. You can. Okay.
Yes, sir.
All right. Yeah. Okay. So today we are going to this part two of this hypothesis testing, and we'll go one by one. Okay, and there are a lot of things that in the outline it shows null and alternative hypothesis, test static, p-value, significance level. In any way, you don't need to think so much. I'll cover. Already we have discussed about null and alternative hypothesis on the other day, but still again, as I do similar to the other class, I will repeat them. Okay. So uh, prior to that, let us again recapitulate what we did. Okay, and what are those terms? Just like population, or as we know that all possible values. Okay, and sample is that means uh, it is the I mean total uh, I mean you can say total cluster or the total all sorts of data, and sample is that a portion of the population, that is it is the part of the population. And statistical inference is generalizing from a sample to a population with calculated degree of certainty. That means it is just like a you are extrapolating, you are just doing all analysis on your sample. Okay, which we call that is a static, and from which you say that okay fine, it is the generalized form to the population. So in case of population we'll have, so if I just get a sample of 10 or 20 people, and based on them I am trying to make an inference, or I want to draw my conclusion that it's going to happen for the population also, but with a calculated degree of certainty. Okay, that was a degree of certainty is that confidence level, confidence interval. Okay, now two forms of statistical inference, one is hypothesis testing, another is estimation. Okay, and parameter, a characteristics of population, as for example population mean. Okay, basically we want to get what is the value of population mean mu from the sample mean, that is x bar. Okay, calculated from the data in the sample. So all these things we are again recapitulating, and we are telling in each and almost every class that from the sample to population or whatever we do, all these things that we do the analysis with the sample only. Okay, now that is shown also. Okay, fine. Now yeah, you see that okay, now here as I said that okay, that whatever we have here in data. Okay, uh, that is we call it statistics, and from there we get the inference about the population what would be. So all these inference are basically that comes from this side to this side. Okay, now also we had gone through this thing that we know that if this is a normal distribution, and we know whatever the mu and ACR, okay, standard deviation, and then this comes from sigma divided by root over n. Okay, it describes the behavior of a sampling mean. This thing already we had done, and in the earlier class also we described what is emphasis, it is a hypothesis. Okay, and hypothesis means it can be a prediction, it can be explanation of a phenomenon. So there are several ways, or some people say that it is a relationship between two variables. Okay, uh, just like in Avogadro's hypothesis, it says that okay, fine, the volume of the gas is proportional to the number of molecules. Okay, so this has been okay. Not only that, in hypothesis also they are also verified either through some experiments or through some kind of a proof. In geometrical hypothesis, in our school 9 or 10 standard, we used to prove the uh, either Pythagoras hypothesis or any other geometrical hypothesis. We rigorously used to do the analysis. There we used to put our brain and everything, and almost it's just like uh, a big fighting, almost like there. Okay, uh, so we had already uh, come across with the term hypothesis. Okay, now again all these things hypotheses are coming, but in different context. And uh, for statistics, for statistical things, we want to have a formal definition or how it can be derived and how we can do that. That is, we are going to see. Now, basically, it is a, just as I said, that it is a formal process for making an inference. The nature of the hypothesis testing. Basically, you are giving some kind of a, you had already done everything almost like informally, and we want to have some formal process just to make an inference. Consider many of the concepts of a hypothesis test and look at several decision making situations. Okay, so basically, you have to look into a process, and then you formulating two hypotheses, and then you concentrate on to some kind of I mean particular thing concern, and then you formulate two hypotheses. And as I described also in the earlier class, that one would be just opposite to the other. So there will be one will be called null hypothesis, and another would be called uh, uh, that it is the it is a what that is alternative hypothesis. Okay, now all this hypothesis testing has got steps. Just here you can see null and alternative hypothesis, and then there is test statistic, then p-value and interpretation, and significance level. On the other day, just we had gone through up to this point, and then we stopped. Okay, because we have to proceed one after another stepwise. Otherwise, in one day, it's just like you have come to this stage. That means you didn't do everything in just one shot. You first did your high school, then you went to your higher secondary, then you did okay, fine. In first year, you learned some mathematics, then you went to your particular branch, there you learned something, also associated other departmental subjects. Then you have come to now whether you now proceed to your master's degree or PhD or whatever it is, or you just go to your professional life, there you apply. That means you are going step by step. Okay, so similar to that, this hypothesis testing has got several steps. So some of them are this. So we had already gone through this, and then we will come one after another. Okay, so that's the reason we want to go one after another. Okay, And we told also other day that hypothesis is a statement that which is something is true. Something. What is that something? And that's statistical hypothesis test. That means a process by which a decision is made. So this test is nothing but a process is made between two opposite hypotheses. That means the whole thing is just based on these two opposing. They are formulated so that each hypothesis is one is negative. If it says okay, fine, I go towards east, another one says no, I go towards west. So if one of them is true, that means the another is bound to be false. So if one of the hypotheses is tested in the hopes that it can be shown to be improbable occurrence, thereby implying that the other. So if the first hypothesis is, if it is found that if it is not valid, that means the second hypothesis is valid. Okay, so if one is not valid, that means the second one is valid. Vice versa. If first one is valid, that means second one is not going to happen. Okay. So, so there is nothing much, and as I said, I did not change this thing okay, as I already looked into that particular book there where it was H was written. But in general, okay, if in question it comes, or if you look into any homework or any book, you may come across that it is H1. So alternative hypothesis is basically denoted by H1, or some books they show it as HA. So it is different notation. It varies from book to book, but it means the same thing. Okay, so null hypothesis, it is shown by H0. This hypothesis is to be tested, that assumed to be true, and that one statement is formulated where the population parameter has a specific value, and that is the starting point. And in the alternative hypothesis, okay, it would certainly uh, take the population parameter which is quite different from this particular specific value. Okay, particular or specific value. That's why it says it is a value that is different in some way from the value given in the null hypothesis. Okay, so if there is rejection, that means if it is found that it is not going to be valid, or if it doesn't hold good, okay, then that means this alternative hypothesis is true. That's what it says, that imply likely truth. That means if this one doesn't work, that means certainly this is going to be valid. Okay, so that's in brief. Just like other day we also gave example of a pain reliever, whether it is better than the another new pain reliever. Okay, so maybe one, let's say one drug company, or okay, a medicine okay company, they have formulated another new uh, pain reliever. Okay, so it is just how much is your that pain that is relieved. If it is one is better than the other, so if it is found that the new pain reliever is no better, that means it doesn't do a good job than the pain leading already market existing pain reliever, then we say it is H0, that is it is null. And also the reverse alternative hypothesis is, if we can find that the new pain reliever, its performance is better and it lasts good, that's what it says. Okay, that means its performance is better than the existing one, so it is the alternative hypothesis. So in this way we can just formulate what is null and the alternative hypothesis. So if some kind of a problem or an example is given to you, you would be able to uh, formulate So that is just the formulation part of this, okay, that hypothesis testing. Okay. So in null and if anybody wants you to work out and ask you to get the null and alternative hypothesis, that means your research question or the example, you have to convert it into null and hypothesis. And the null hypothesis is a claim of no difference in population, okay, and H0 is false. So if this is false, then this alternative hypothesis is going to be, or it is going to be valid. Okay, so the thing is that for that, what you have to do, that you have to collect data. So whatever, if you want to prove, that means you have to data and seek evidence against H0 as a way of bolstering HA. Okay, that means if you want to make this one hold good, that means alternative hypothesis, that means you have to collect the data, and then based on the data you have to say whatever I am getting, that is that holds good, whereas this whatever the claim that has been made in null hypothesis is not good. If it can be proved, that means your job is done in that case. Okay. Now, let's say another example, illustrative example. Let's say in year 1970, 20 to 29-year-old man in a country had a mean, uh, okay, body weight of 170 pound, and standard deviation was 40 pound. Okay, you can understand that it is pound, maybe some British or somewhere in some other western country. So we test whether the mean body weight in the population now differs. So let's have this one H0, okay, where mu is equal to 170 and no difference. The alternative hypothesis can be either HA, mu can be greater than 170, one-sided test, or mu not equal to 170. So if,
Excuse
hello,
me, sir.
yes,
Sir, is in this equation a null hypothesis H0 mu less than equal to 170 नहीं हो सकता क्या?
you can have this thing, then you have to put this one, okay, that I say the alternative hypothesis mu is equal to 170. So vice versa, one has to be against the another one, okay, that you can
Sir,
do.
alternate hypothesis showing mu is greater than
Okay,
170. So null
okay, you are
hypothesis may be mu less than equal to 170.
that you can do. Okay, fine. Okay, that here it is just we want to see that question is that whether the mean body in the population now differs or not. That means
Oh,
I want to say 170 or not. Okay,
okay,
it is not said that whether it is greater than or less than. Okay, what you are saying is this: first one is mu 170, and you want to say that okay, mu is less than 170. Is it that
less
what
than
you
or
want to?
equal to. Yes,
Yeah,
yes, yes.
less than or equal to. Okay, but the question was not here. Question was that whether this one is 171 is holding good or not. Otherwise, you
Okay,
can also prove the same thing, just as you said. Na, one is greater than, and only thing is that you have one has to be just reverse, and you have to prove. Okay, that's
okay,
the
sir.
way you have to. All right. So basic essence is that one has to be just the reverse of the other. Then your aim is fulfilled. Okay. Uh, okay. Now, as I said, that there is also another step, that is a test statistic. This is one example of one sample test of a mean when sigma is known. Okay, in this problem, sigma is known. Okay, so you can use that just if you recall that equation, that z is nothing but there what we used to do, that x minus mu or x minus x bar divided by sigma, you recall? Okay, in most of the problem we used to do. So similar to that, here this has been used. So mu is equal to the population mean, assuming H0 is true, and you derive this equation from here. So next is that it is just you plug in all those values. Okay, because if you go back, you see this standard deviation is already given. Okay, sigma is given as for 40. Okay, here. Okay, and mu is given. So what you do here is basically that okay, for sample mean 173, what would be the z stat value? It is just for example that uh, if we found a sample mean of 173, what would be the case? Okay, so it is just, it has been put here that how this z value, that it gets change, whatever would be the value that you calculate here. So it is I mean, it is not hard and fast rule that you have to get exactly that. So here what is done, that n is equal to taken as 64, and AC is calculated here, and Z stat value is 0.60, it has been calculated. Now also there another step was estimation of p value. Okay, now let me show this thing. Yeah, the p value answer the question. What is the p? Is actually basically probability of the observed test statistic, or one more extreme, when a0 is true. This corresponds to the area under the curve in the tail of the standard normal distribution beyond z stat. So what it has been done in the previous, okay, that we have already calculated this value. Okay, that means you have to do all the whole exercise, then only you can come into this. Okay, which was earlier just only one problem, just to get the value of z value. Okay, so now convert the z statistics to p value. As you know, from the normal distribution, you can look into the from the value of z, you look again to the table. Okay, and once you have this z value, okay, you can calculate what is the probability. Okay, once you know what is z value, from there you get the, so for ha, you are somebody was telling now. Okay, similar to that, you see, if mu, okay, that mean value, okay, is greater than mu zero, the probability z stat right tailed beyond z stat. Okay, and ha, that means this is one is that, okay, fine, if it is not 170, if it is more than 170 or something like that, then what would be? Okay, so it is right tail beyond z stat, and uh, this one mu less than mu zero, that left tail beyond, okay, z stat, and mu is equal to mu zero, p is equal to oh, 2 multiplied by 1 tailed p value. Now again we will see this thing how they have calculated. So use table or software to find these probabilities. Okay. And so either you have your table with you to get the z value, or if you have software, from there you can calculate. So you see here, as I said that, okay, one-sided p-value of z star of 0.6. Okay, you see that it is 170 is that this population mean here, and if it is 173, that means 0.6. So right side is this 0.2. You have to get this value from the table. Okay, so from the z value, you get that from the table that this is the area under the curve. The distribution of x bar and z stat if H0 were true. So if you think that H0 is valid, then this is going to be the case. And again, okay, one-sided p-value for z stat of 3.0. So if it is 185 and 3.0, there the p-value has been found to be 0.0010. So you please check this thing. Once this thing is again given to you, you look into, once these slides are given, you just calculate. Maybe sometimes they put it, it may not be exactly same. That's why I always say that you check on your own. I did not check this thing. Okay, so you search from the table and look there what it is exactly. Once you do that, then your confidence will be built up further. Okay, so you can do anything over there. And two-sided p-value. Okay, see, as I was saying in the earlier one, it was said that half of p, that means this side and this side. Okay, if it is one-sided p is equal to 0.001, two-sided p means twice multiplied by 0.001. Okay, if one-sided p is 0.2743, then two-sided p will be this much. Okay, so that's what it was said. What it was meant by there, it is now you can see through only your drawing will give you better concept. Instead of speaking so many words or you write something, that's why I always say that that you do it extensively and you draw something in your attached page. Same for your homework also. Okay, so two-sided HA, consider potential deviation in both direction, double the one-sided p-value. Okay, so p-value answer the question, what is the probability of the observed T static when H0 is true? The smaller and smaller p-value provides stronger and stronger evidence against H0. Okay, and small p-value means strong evidence. So you can also see from there that if this is okay, if this is smaller value, that means what is going to happen there? Okay, that your distribution is going to be like this totally. Okay. Now, okay, there are some convention that are followed. One is that what are those? That 0.10, if p is equal to if p is equal to 0.10 and 0.05, that means marginally significant evidence. In general, p values are taken if there are some example or some question is asked either in homework or in your example and nothing is mentioned, you should take the value in between this 0.01 to 0.05. Significant evidence against H0, p less than or equal to 0.01, highly significant evidence against H0. So these are the convention in general, these are followed. Okay, just like 0.27. So 0.27, it doesn't lie within this thing, non-significant evidence against H0. And 0.01, that lies here. Okay. Highly significant evidence against H0. Now, I'll come to this example later on, okay, because everything has got some relevance, and if they are explained at only at that time, then it becomes clear. Just like as you have already done some exercise with z value, so now it z value is now more clear because you have already looked into the table. So had I told this thing in the very first class or the second class, it would have been just a, you would not appreciate that in that case. Okay, you would not like that at okay. So let's take your attendance now. Okay, let me call okay, your name, and then you please tell me whether you are there or not. Deepak Pali. Yeah, just your turn on your okay, speaker on. Okay,
Yes, sir. Yes.
Deepak Pali is there. Okay, all right.
Yes, sir.
Prem Prakash Singh, Puneet Karsal,
Yes,
Rajinikanth.
sir. Sir.
Okay, yeah. Ravi Shankar Kumar, Sajid Kamar, Sajid Satendra, Satendra Datre.
Yes, sir. Yes, sir.
Okay, Siddharth Vikram, Sunil Gupta,
Present, sir.
Suraj Kumar, Suraj Kumar, absent. Okay, Sai Krishna, Harshit Agarwal, Keshav Gupta, Keshav Gupta there. Hello, Keshav. Keshav is not there. Pawan Kumar Kilari,
Yes, sir.
whoever has given your attendance, you just mute yourself.
Sir, Pawan Kumar present, sir.
Yeah, I have got it. Kundan Kumar,
Dhananjay Kumar Singh, sir.
I do not want this other speaker to be on. If you have already,
Sir, Dhananjay Kumar Singh, sir. You are mute.
So please unmute yourself now. So your voice is not visible. Your voice is not audible, sorry. Siddha sir,
So your voice is not coming.
Siddha sir, please unmute yourself. You're not audible.
hear me? Can you hear me?
Yes, sir.
Yes, sir. Yes.
Yes, sir.
Yes,
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
You can hear me. That's okay. So let me again go. Nand Kumar Singh is not there. Sunil,
Present, sir. Present, sir.
at that time you are not there. Nand
No,
Kumar,
sir.
Nikhil Suneja,
Present. Sir, I was
Nikhil
present.
Suneja,
All. No, sir.
Yes, sir.
Nikhil Suneja there. Okay,
Yes, sir.
Nikhil Suneja there.
Yes, sir. Hello. Yes, sir. Nikhil. Nikhil Suneja.
Okay, Veer Pratap Singh, Meena, Meena,
Yes, sir. Present, Meena.
Utkarsh? Utkarsh?
Yes, sir. Present.
Utkarsh Singh?
Present, sir.
Kunal Kumar?
Yes, sir, I am here.
Josh Khandelwal? Amitesh Raj?
Yes, sir.
Dhananjay Kumar Singh?
Present, sir.
Avinash Raj? Ashish Kumar Gupta? Avinash Kumar? Avinash Kumar? Abhishek Kumar?
Yes, sir. Present, sir.
Obhinav Naveen Sinha? Okay, fine.
Yes, sir.
Uh,
Present. Abhinav Naveen Sinha.
Abhinav Sinha?
Yes, sir. I am present.
Okay, you don't know your name. Okay,
No, sir.
fine.
My mic was not working.
Okay, all right. So again, we go back. Okay.
Sir, my
the
name
next-
is. Sir, I haven't got my name.
What is your name?
Male Bhargav or Bhargav Male.
I called your name.
Sir, when you have called, your mute, you have kept your mic mute. I'm
Okay.
listening from the starting.
You are listening from?
I am listening the class from the starting onwards, sir. I
Okay.
haven't.
Okay. I have got almost
sir.
everybody. Okay.
Sir, you were on mute. Sir. Bhargav was there.
Yes, sir. Your voice was not coming.
Yeah. Okay. Other people could hear that it is my voice was not. They could not hear. Okay. All right. So let's again go back. Okay. Mm, so we'll not talk about this example. We'll ask this about this thing later on. Okay. So basically, okay. So level of then again there is also other part is level of significance and state static. Okay, test static. Can you hear me?
Sir.
Okay.
Yes, sir.
Yes, sir.
Okay. Now there are a couple of types of errors. So I'll have to again first explain to you what are the types of errors. Then only you will understand. Otherwise, this part will not be okay clear to you. Uh, uh, let's show you some example. Okay, just like uh, here, hypothesis testing for a random sample of n is equal to 25 measurements of chest circumferences from a population of newborns having sigma is equal to 0.7 inch. Provide a sample mean of x bar 12.6 inch. It is likely that population mean has the value mu is equal to 13.0. Okay, so what it has been done is basically a sample is taken. Okay, and the sample you can see that it is 25. Okay, uh, that n is equal to number of samples basically is 25. Okay, and there the value of sigma is 0.7. Okay, and sample mean has been found to be this. Now from here we have to get the okay that whether the population mean it can happen mu is equal to 13. Okay, that means we have already gotten x bar is equal to 12.6. Okay, now hypothesis is that we can have that first we start with the null hypothesis. Okay, we say that mu is equal to 13.0 versus h1, that it cannot be 13.0. So one thing is that, okay, let's assume that 13.0 is correct. Okay, that is H0, and the other one is that H1 is not okay, that it is not 13.0. So that is your H1. Okay. Now, also the assumption that has been made that random sample from a normal distribution with 0.7 inch, that is already given there. Okay, and we, as we said that we, as the alpha level, okay, that we say that it has to be within that, or p value, that is probability. Okay, just earlier we showed there. Some books or some examples show it as alpha, some people say it p. So it is 0.05. Okay, so that is already, let's say we is assume that. Okay, uh, and first we go through this, that test statics, the critical region, they reject H0, mu is equal to 13.0 if the value calculated for J is not between plus minus 1.96. Now, where from this plus minus 1.96 come? Can anybody tell?
The value of Z.
Right. But what corresponds to that Z? That value gives 1.96. Okay. So you look there. What is the value of Z that gives, okay, um, that 1.96 corresponds to what? Okay. So
95%.
95%, exactly. That's what I wanted to know. So if you can recall that 95% corresponds to this one, okay, that's why I wanted to see that it is, once you say that this is probability is this 0.05, that means only left out with 95%. So this Z value is not in between. So in the examples, similar things are given. So you have to figure out, you have to understand that this 1.96 has come from there. Okay. So, and Z value, if you take this thing as 13.0, so it is x minus mu, that is this, and this comes from here, and you substitute all those things and you come minus 2.86. Okay, reject H0, mu is equal to 13.0, since the value calculated for Z is not in between plus minus 1.96. Basically, that means that if you are plotting something like that, that, okay, it is in one side it is 1.96, in another side it is minus 1.96, right? Okay, so here in this is your 0, right? And minus 0.286, that goes beyond this one. Okay, so it is much beyond this plus minus 1.96. So we have to reject H0. So that's another way that that's the way to solve your problem. So if this kind of problem is given, from there you can establish the null hypothesis, and from here you can say this thing that this H0 or the null hypothesis is not correct. So this 13, okay, it is not likely to happen. That it's not likely, because this thing does not hold good. Okay, so this was pretty simple once you understand this thing. Otherwise, it will always look that you cannot. This test was performed under the assumption that mu is equal to 13.0. Our conclusion is that our sample mean x bar is equal to 12.6 is so far away from 13.0 that we find it is hard to believe mu is equal to 13.0. Okay, so that is our observed value x bar is equal to 12.6, but the sample mean is too rare for us to believe that mu is equal to 13.0. So these are all given in the book in their own language, but the essence of this thing is up to this much. Okay, just for this example it was shown. And if you want to analyze further, then you can have a look that okay, if your this is 13.0, 13.27, okay, accept that mu is equal to 13.0, and if you take this thing and what it would be, it would look like, and then in that case you reject this thing. Okay, so it is just shifting. Okay, you're taking the mu value as 13.0 and how it would look like. So further analysis has been made with how it looks like, and for this sample mean n is equal to 25. Okay, and here it is done that okay, this sigma x is equal to 0.14, and all these analysis have been done, and it was shown how it can be, how it looks like if you take other value. uh, so I'll give all this thing and you please look into, and I will give you also some example from some website. You please look into that also. Can you hear me? Hello.
Sir.
Yes.
Yes, sir.
Okay, you can hear me, so no problem. Okay. uh, so whether Dhananjay is here?
Sir, I'm here.
Dhananjay,
Yes, sir,
you
I'm
are
here.
acha, okay, fine. Your friend Nand Kumar nahi hai na? Okay.
Yes, sir. I'm present.
Okay, no, you were not there at that time, I don't know why.
Yes, no, sir. Your voice was not coming. You muted yourself. That's why
Uh,
I was
acha,
only saying that your voice is not coming.
yeah, that's why I'm checking. Nikhil Suneja. Nikhil Suneja. Nikhil Suneja is not here. Deepak Pali,
Yes, sir.
you are there, na? Okay.
Uh,
Sunil Gupta.
Yes, yes, Sunil Gupta is here.
Okay. Utkarsh Singh. Utkarsh Singh. Rajinikanth.
Yes, sir.
Okay. Kunal Kumar. Kunal is not here. So
Yes, sir.
second
I am
time.
here. Hello.
Where do you go? Can you not hear? Everybody can hear. You cannot hear. I don't know. Uh, Abhinav Sinha. Abhinav Navin Sinha.
Yes, yes. Abhinav. Yes, sir.
Hello.
Yes, sir. I am here. Hello. Hello.
Okay. Abhishek Kumar.
Yes, sir, I'm here, sir.
Okay. I'm checking. That's why you right now you were. Okay. Avinash Raj. Avinash Raj. Now other people can hear, but if he cannot hear, then it's his problem. All right. Okay. So we stop here and we'll see you next time. All right. Huh?
Okay, sir.
Okay. Okay. Thank you.
Okay, sir. Thank you.
You're welcome. Okay. Bye. Good night.